Good afternoon, everyone.
Good afternoon, ma'am.
Good afternoon.
Okay, so in the previous few classes, we see what is entity relationship model. Today, we'll see what is relational model. Yeah, just uh, keep yourself in the mute, everyone. Okay. So we see what is entity relationship model, and I told you that it is a conceptual model which is used to represent our database, isn't it? So same as that, this relational model is also a conceptual model. Means this all this model, every model that we have seen in the previous class, this model they are used to represent the database in a conceptual way, in a theoretical way. Okay, means they means we do not need, while designing a database, we do not need to know how physically the database are stored in our memory. So this is just conceptual thing. We are just representing the database in a particular model which is which is means which is more comfortable with us, which is more readable to us, which is more understanding to us. Okay, so relational model is also such one such kind of model by using which we can represent the conceptual model of a database. So and this relational model is the most popular database model. Why? Because by using the relational model means we will be able to represent every details, every small details about a database using relational model. In the case of entity relationship model, what happened is we were able to represent only the entities and their relationship, isn't it? The relationship between the entities and the entities. So those things we are able to represent in the ER model. We were not able to see anything, means the values that will be stored in the database and all the or means and
Ma'am,
every yes.
excuse me, ma'am. There are some people waiting to join.
Yeah, I can see. Okay. So this individual entities, we are not able to see the details about the individual entities in the ER model, isn't it? So we were only able to see the entity types and the relationship types between the entity types, isn't it? But here in the relational model, what happened is every details, every small details about the database, we will be able to represent it in the relational model. So that is why it is a very popular model. And other few things, like I will just tell you some history about relational model. So those database which use relational model to represent itself, those means if there is a database and it is using a relational model to represent them, and this database are known as relational database. Okay, this database are known as relational database. So if we have a relational database, these are all theories. Okay, whatever I'm going to tell you now, I will just, these are all theories. So this relational, if there is a relational database, this relational database is also exists in theory. Okay, so this, if there is a relational database, then it is a database which is having in many datas, isn't it? Then there should be some language which will be retrieving, which will be used to retrieve information from the relational database, isn't it? So there are two types of such language, which can be used to retrieve information, which can be used to write queries, is in order to retrieve information from the relational database. And those languages, there are two types of language. One is known as relational algebra, and another one is known as relational calculus. Okay, So by using relational, either relational algebra or relational calculus, we can write queries. And this query, it will be used to, as it is a query, it will be used to retrieve some information, isn't it? So it will be used to retrieve information from the relational database. Okay. So again, this relational algebra and relational calculus, I'll tell you, this exists in theory. Okay, so we can't just write if we are if a database is there in our computer or whatever machine we have, and if we write something in relational using relational algebra to retrieve information from our database, then it is not means it is not like that. Okay, relational and algebra and relational calculus is a language. Yeah, it is a language, but this language means it is just we can write it only, means it exists only in theory. Okay, it is just like your mathematics. You can say it is a mathematical language. Okay, so it is just like a mathematics. In a mathematics you can write equations, isn't it? Same thing here in relational algebra. By using relational algebra you can write these equations and these expressions. Okay, so this expressions, single expressions, we can say the single expression is a query. Okay, so this expression can be used, which is written by using relational algebra. It can be used to retrieve data, retrieve information from the relational database. This, which is also exists in the theory. Okay, so this, I'm just introducing what relational model is, and we'll see what this relational algebra and relational calculus in the later classes. So here we have this relational algebra and relational calculus as a language which can be used to retrieve information from relational model. So these are all related to our relational model. Okay. And then if we have, so from here, means we have the, as it is as I have already told you, this is a very popular model. We have the relational model, isn't it? The relational model is it is first introduced by EF Cott. Okay, so this means the relational model is introduced by EF Cott, and then after that he also introduced the relational algebra and relational calculus. Okay, so because of this existence, because of this existence of the relational database and the relational algebra and relational calculus, what happened is the RDBMS, RDBMS, which is available in the which is commercially available in the market, and this comes. Okay, means they are all, the RDBMS are based on the relational database. Okay, so in RDBMS, what happened is whatever database, as you can see, they will be represented by using relational models. So that is why this kind of databases are known, this kind of database management systems are known as RDBMS. Okay, so the first commercially available RDBMS is the Oracle. Okay, by using Oracle, we can, means Oracle, in this Oracle particular platform, by using which we can and create our databases, they use the relational model in order to represent the databases. That is why it is known as RDBMS. Okay, so now we can create, means actually in actual way we can create our databases. Okay, not just in theory, by using the RDBMS, isn't it? If we have the actual our actual database, then there should be a language by using which we can again retrieve the information from the database. And one such language is your SQL, structured query language. And this structured query language is based on relational algebra. Structured query language is available to us only because of relational algebra, because relational algebra is a core of structured query language. Okay, what is available in the theory, because of those things we have our RDBMS, and then we have our SQL. Okay, so SQL means it is as I told you that our relational algebra is the core for SQL. Whatever query it means somewhat They are everything, every terms and terminology that we use in SQL and whatever we use in relational algebra, they are somewhat similar. Okay, so we will see all these things later on. So you just remember that relational model is a very popular model because it is able to represent every small details about the database. Okay, so let us come to our model again, relational model. So what is this relational model? This is used to represent the database as a collection of relations or tables. Okay, here tables. This tables is the tables that you know. Okay, so tables means it will have, as it is a table, it will have rows and columns. It will be made up of rows and columns, isn't it? So I'm just using this table so in order to make you understand. But the term, the actual thing, the formal term that we will be using is relations. Instead of tables, we will be using relations. Tables are called relation in relational model. So that is why it is having the name relational model. Okay, so it is used to represent database, and a database is going to be a collection of such relations. Okay, so the relations that we are using here in relational model and the relationship that we see in the previous classes, they are totally different. Okay, just don't mix up with these two. Here the relation represent a table. Okay, table, and there in the ER model, or even here also in relational model, we are going to use the term relationship, and that relationship is going to be a relationship between something, two things, or in the ER model, it is going to be a relationship between two entities, isn't it? So relational in the by using relational model, we can use data, we can represent a database, and it is going to be a collection of relations. Okay, and here the relations, by using relations, if we say in the means we already know ER model, isn't it? We already know what are entities, what are entity types. So if we say in those things, then a particular relation can be used to represent an entity type. Okay, it can be used to represent a relationship type also. Okay, so everything will be represented by using relations in relational model. Okay, now as I have already told you, relation means it is a table, then it will be having rows, isn't it? So a relation is a collection of rows or records or tuples. The formal word that we will be using is going to be tuples. So we are not going to use rows. This row I'm just giving it in order to make you understand. Okay, so the rows will be named as tuples. Okay, so relations is a collection of tuples, and each tuple is used to represent an individual entity. Okay, so if we have, say for example, a book, and in the ER diagram that we see in our previous classes, in the that one, yeah, library management system, we have the book entity type, isn't it? That book entity type, we can use a relation to represent that particular book entity type. Okay, and this book entity type is a collection of book entities, isn't it? Individual book entities, isn't it? So each row or each tuple in the relation is going to represent such individual entities. Okay, and the rows contains values related to each other. This is something that this is for or this is obvious, isn't it? If say for example, here I have shown the same example. This is the this is a user. This is a user relation for the library management system. So for the particular user relation, what we are having, this is the heading of the columns, isn't it? These are the headings of the columns. But here, these are the attributes. Okay, in the relational model, if in formal terminology, we will be using the term attributes. Okay, so these are the attributes, and the name of this relation is user. Okay, so I can't write the name here, so just know that the name of the relation is this attribute, this one, user. Okay, and these are the attributes. Okay, and attributes are going to be the headers of the columns. Okay, so each here, this is a tuple, this is another tuple, this is a second tuple, this is a third tuple, and this is the fourth tuple. So the relation user has 4 tuples. Okay, and each tuple is representing a particular user of the library. Okay, so it will have a value for the card number, it will have a name for the card number, it will have a name for that particular individual user, it will have an address, value of the address, and it will have value for the status also, it will have a value for the code also. Okay, so here each tuple is used to represent a particular entity in from the ER model that we already know. Okay, so that is why every small details can be represented by using relational model. So that is why it is very popular. So here you can see these are the I have already told you this is an example relation. This is an example relation. The name of the relation is user. These are the attributes of the relation: card number, name, address, status, and code. These are the attributes of the user relation. And the tuples, it is a collection of tuples, isn't it? So we have 4 tuples here in this relation. Okay, 4 tuples. Okay, and in the tuples, the values in each column, okay, the value in each column for a tuple, they are related to each other, isn't it? So when we say card number L001, then we know that it belongs to Bob, isn't it? And when we say L001, then we know that the status is going to be a student, okay, because of this number. Okay, then they are all related to each other. The values that is present in a single tuple, they are related to each other. Okay, so that is why in a row, tuples contains values related to each other. Okay, the next thing that you need to know is the domain. Domain describes the types, okay, that, or you can say the data type of a column or of an attribute. So describe the types of values that can appear in each column or attribute. Okay, so data type of a particular column, particular here, data type of this one, data type of this one. So these are going to be the domain of the attribute. Okay, domain of the attribute. Like we can only have in the address, in the name attribute, we can only have strings. Okay, we can't have numbers or something like that, so, or special characters. Then it is a domain. We are just defining a domain for a particular attribute, isn't it? So such things, such restriction that is given for the values in a particular attribute is known as a domain of that attribute. Okay, relation schema. So what is this relation schema? When we when we have a relation, and when we say, when we ask what is going to be the relational schema of that relation, then it is going to be the name of the relation and the attributes of attributes of the relation. Okay, we can't have the values. So this one here, see, user is going to be the name of the relation, and these are the attributes of the users, isn't it? So this is a relational schema. Okay, or in another way, you can just delete these things. If we delete this thing, and if we just write the name of the okay, I can't add text here. So the name of the this one, the name of the relation, you have to write it here, like the user. Okay, user, if you write it here, and if you if you have means the name of the attributes only here, means without the values, then without the tuples, then it is a relational schema. Okay, but with the values at that instant of time, it is known as relational state. Okay, actually means it is defined here. Relational schema, relation name and a list of attribute names. It is known as relation schema. And what about relation state? Relation schema plus list of attributes at that instant of time, and it is known as relation state. So what is the difference between relational schema and relational state? It means it gives the definition of that particular relation, only the definition. But here in relational state, we also have the tuples for that instant of time. Okay, so that is the difference between relational schema and relational state. Okay, and what is the degree of a relation? Number of attributes in its relational schema is going to be the degree of the relation. Okay, so these are some of the terms that you need to know about relational model. We have relation, and then we have tuples, we know attributes, we know domain of the attributes, what is the domain of the attributes, and then we know what is relation schema, we know what is relation state, and we know what is a degree of a relation. Okay, degree of a relation is going to be the number of attributes present in that particular relation. Okay. Okay, so this is an example relation. If you want to know, this is an example relation which is representing the user entity type. Okay, and even the values, even the details about the use, whatever means the individual users are also represented here in this particular relational model by using this relational model. Okay, now let us see the relational model constraints. There are many constraints. Constraints are the restrictions, isn't it? So if we are using a relational model, we can also define some restrictions on our models. Okay, so those restrictions that we can provide on the relational models are, the first one is domain constraint. So domain, we already know domain, isn't it? And what is this domain constraint? So it is used to specify the values that can appear on a particular attribute. Okay, the values that can appear on the particular attribute. So by using domain constraint, we can give a restriction on the values that can appear on for a particular attribute. We already know this, isn't it? We are just defining the data type of an attribute, isn't it? So it specifies that within each tuple, the value of each attribute must be okay. So it should be an atomic value, and it should also be from the domain of that particular attribute. Let us see the same example again. So it should be an atomic value. Atomic value means it can't be multi-valued and it can't be a composite value. It means particular attribute, this card number, whatever attribute we have in a relational model, it cannot be a multi-value attribute and it cannot be a composite attribute. Okay, so it means it should be an atomic attribute. That means whatever value that we are going to give here, it should be atomic. Okay, a single value should be provided, and that value should be under the restriction that we applied here as a domain of the card number. Okay, so that is a definition, that is the thing that you need to know about domain constraint. The next constraint that we have in our relational model is key constraint. So what is this key constraint? Key constraint, in order to understand key constraint, you just need to know some of the few things about keys. Okay, the first one is super key. So super key, it means it is a set of one or more attributes which can be used to uniquely identify a tuple. Okay, so this we already know. What is key? We already know from entity relationship model, isn't it? So when we say super key, it is the same key that we know. It is the set of one or more attributes which can be used to uniquely identify a tuple. Okay, so when we say key in a relational database, then what is this? It is also a super key. Okay, it is also a minimal. You can say it is a minimal super key. Okay, why? Because if we remove anything, means it is a super key. If we remove anything from that super key, then it is no more a super key. Means it will not be able to uniquely identify a tuple. If we remove a particular attribute from the super key, then those super key, those minimal super key are known as key. That means all keys are super keys, but all the super keys are not keys, isn't it? There might be some super key from where even if we remove one or two attributes, they still, the definition of the super key still exists. Then those super keys are not keys. Okay, so just remember that keys are the minimal super keys. What about candidate keys? Candidate keys, they are candidate keys means a particular relation can have more than one key. Okay, it can have more than one key. From all those keys, such means if we have more than one keys, then those keys are known as candidate keys. Okay, a relational schema can have more than one key. Each such key is termed as candidate key. Okay, and what about primary key? So this is the most important one, primary key. So whatever candidate key we have, if we have more than one keys, then those keys are known as candidate keys, isn't it? So from those candidate keys, we have to select only one of them, only one candidate key. And as a database designer, we will make it the key for that particular relation, and that will become the primary key. Okay, so we can have super key, candidate keys from all those things. We have to remove everything, and we have to we have to select only one candidate key, and that candidate key we can make it the primary key. Okay, now I will define what is this key constraint. The key constraint means the value for the key attribute, the value for the primary key should be unique. Okay, it specifies that the value of the key attribute for different tuples in the relation has to be unique. Okay, so for every tuple, the value of the primary key should be unique. So that is the key constraint. That is the definition for key constraint. So we can provide such key constraint in our relational model. The next constraint is constraints on null value. Means in a particular attribute, for a particular attribute, we can specify that whether null values are allowed or not. Okay, so such constraint that we apply is known as constraints on null values. If we say in this particular uh, in this particular relation, if we say that the name attribute cannot be null, then when we provide values for each and every tuples, we have to provide value for this name attribute. We can't just leave it blank. Okay, so such type of constraint can also be applied. So those constraints are known as constraints on null values. The next thing is entity integrity constraint. Entity integrity constraint means for the key constraint, means the primary key of a particular relation cannot be null. Okay, it states, means it is a definition for entity integrity constraint. So if we have a primary key, so for example, in this particular relation, we can define this card number as a primary key, isn't it? We can define this card number as a primary key. There are more than one super key here. You can use this card. I mean, card number is also a candidate key. Code is also a candidate key, isn't it? Because they can uniquely identify the tuples. But here from all these candidate keys, we can select only one and we can make it the primary key. So I will select card number. You can select code also. Okay. But for me, I will select card number and I will make it the primary key. Okay. If it is a primary key, then the entity integrity constraint says that the values means we can't just give the value null for this primary key. Okay. It cannot be null. Okay. So that is entity integrity constraint. The last constraint is referential integrity constraint. So two relations, if we have two relations, so it has to be defined in two or more relations. So I will use two relations. We are going to have two relations. Okay. And these two relations are related to each other. Okay. If they are related to each other, then what will happen is one relation is going to be referring to another relation. Okay. So this I will explain it with an example. For example, here we have two relations. One is user relation and another relation is the book relation. Okay, user relation and book relation. So here what is happening is if they are related to each other, then and there should be an attribute. There should be an attribute in one of them. Let us see. Okay, here see this attribute borrower. This attribute borrower attribute in the book relation. This borrower relation is the card number, isn't it? Is the card number of the users, isn't it? That means this borrower attribute is referring to the card number of the user relation. Okay, so by using this borrower attribute and this card number attribute, the user relation and the book relations are related to each other. Okay, so they are related to each other because of this card number and the borrower attributes. Okay, and this borrower is referring to this card number. If it is referring to some of the primary key, this is the primary key in the user relation, isn't it? So if there is an attribute which is referring to the primary key of another relation, then this particular attribute is known as foreign key. Okay, this attribute, borrower attribute in the book relation is the foreign key referring to the primary key of the user relation. Okay, so if such thing exists, then what happen is the referential integrity constraint, and means it specifies that whatever entities we have here, means whatever tuples we insert here, it should have a value for this borrower which is already exists here in the card number. Okay, that means we can insert a tuple which is having the value L002 for borrower because L002 exists here. Okay, and L004 we can also insert this value because L004 is there. But we can't insert a tuple which is going to have a value like L005 here in the book relation because L005 does not exist here in this reference card number attribute. Okay, so this is the definition of referential integrity constraint. I'll just read it out. It is specified between two relations and is used to maintain the consistency among tuples in the two relations. It states that a tuple in one relation that refers to another relation must refer to an existing tuple in that relation. Okay, so it should refer to an existing tuple. Whatever value that we are going to have here, it should refer to an existing value that we are having here. Okay, so that is the definition of referential integrity constraint. So from here, certain things are, certain terms are, means you need to define for referential integrity constraint. We already know what is foreign key, isn't it? We are referencing relation. So here, The book relation is going to be the referencing relation, and the user relation is going to be the reference relation. Okay, book is having the foreign key, isn't it? And this foreign key is referring to the card number primary key of user, isn't it? So that is why book is going to be the referencing relation and user is going to be the reference relation. Okay. So a few things you need to know about relational model. We'll see different, means other examples of relational model in the next class. For now, if you are having any doubt in any of the terms that we see so far in this relational model, you can ask. I will just briefly tell you whatever we have learned in today's class. We know what is this relational model. Relational model, same thing, it is a conceptual model which is used to represent the database, isn't it? So it is a collection of relations. When we have a database representing by a relational model, then it should have more, means one or more, it's going to be made up of one or more tables or one or more relations. Okay, so that is why it is used to represent the database as a collection of relations or tables, isn't it? And when we say a relation, it is a collection of tuples. Okay, it is a collection of tuples. And tuples contains values related to each other. So for a single tuple, when we say a single tuple, the values that we have here, that is L001 is related to Bob, and again Bob is related to this address ABC, and again Bob and L001 and ABC, all these things are related to the value, this student, okay, and the code 001, okay, they are all related, isn't it? The values that exist in a particular tuple, they are all related to each other, isn't it? That is why it is saying that tuples contains values related to each other. Okay, so when we say a domain, it is a data type of a particular attribute, isn't it? So we know what is domain, we know what is relation schema, it is the relational name and the list of the attributes. We know what is degree of a relation, it is the number of attributes, isn't it? We know what is relation state, okay? And then we know what is domain constraint. These are the constraints that we have in our relational, that we can apply in our relational database. We know what is domain constraint, isn't it? Means some domain, we have to define a domain of a particular attribute, and whatever value that we are going to give in that attribute should be belonging to that domain. Okay, it cannot be outside the domain. It should be inside, means it should be a value inside the domain. Okay. And key constant, for key constant, we have the primary key. When we say a key constant, then it is related to the primary key. The other keys that you just need to know the definition for the other keys, but the actual key that we have in our relational model is the primary key. Okay, for each relation, there should be a primary key. Okay, which is uniquely identifying the tuples. So for key constant says that key constant says that the value for the primary key should be unique for each and every tuple, isn't it? So that is the definition for key constant. The constant on null values means for a particular attribute, we can define whether null values are applicable or not applicable. Okay, so those constraints on null values can also be defined on the relational database. And other constraint that we can have in our relational database is one is entity integrity constraint. So this is related to the primary key again. Okay, so if we define the key constraint, then this already comes with the key constraint. We do not need to define it again. Okay, because if a particular attribute is defined as a primary key, then for sure we can't put a null value in that primary key. Okay, so null values are not allowed for a primary key. The last constraint is referential integrity constraint. So this is for two relations which are related to each other. Okay, so if a particular tuple of a relation is referring to another tuple of another relation, then it should refer to an existing tuple. So that is a definition of referential integrity constraint. Any question? Any doubt? Are you students understanding whatever I'm explaining?
Hello.
Yeah.
Yes, ma'am.
Ma'am, actually, there is one doubt.
Yes.
Like in referential integrity, ma'am, like the user is the reference table and someone is referencing it, right? So, like if we delete one row from it, will it affect the other table also?
Here, say this is the referencing table and this is the reference table.
Yes.
Okay, so whatever tuples we delete from book, it is not going to create any problem. Means we can delete anything from the referencing table. But if we are going to delete it from the user, okay, then you means there will be an error message to you. An error message will come up as you can't delete it because it is referencing by many other tuples from the book relation. Okay, so and means you can't delete it. You won't be able to delete it. You have to delete all the tuples which is referencing to it first before deleting it. You getting my point?
Yes, ma'am. Clear.
That means if you are going to delete this L00 means this tuple, this second tuple, then you won't be able to delete it from user. You first need to delete this tuple and this one, these two tuples from the book relation. After that, only after that you will be able to delete it. Do you get it?
Yes, ma'am.
Any other doubt? Okay, then response your attendance. Abhijit Anand,
Present, ma'am.
Akash, 2,